The endogenous lipid transport pathway also involves the liver. However, this is independent of the gastrointestinal tract, so we are not now dealing with cholesterol and triglyceride transport coming from dietary sources. This is hepatically derived lipid, which is being packaged into the VLDL particles and then transported throughout the body to deliver both triglyceride and to some extent cholesterol to various cells and tissues. So again, I need you to think of a factory analogy, but in this case this is not a single pass type of factory. In this case we have a factory which is capable of taking raw material from circulation. This includes the triglyceride and cholesterol, repackaging this into the transport lipoprotein, in this case very low density lipoprotein or VLDL, packaging this into VLDL particles and shipping it out into circulation to distribute its lipid through to the various cells. It's capable of taking dietary In this particular case, the factory, being the hepatocytes, are capable of taking previously produced triglyceride and cholesterol, or producing its own fatty acids, triglycerides, and even cholesterol, and then packaging them into VLDL particles for transport to other cells and tissues. So this occurs in a similar fashion to that which we described in the exogenous pathway, where these delivery trucks or lipoprotein particles are delivering the lipid to the various cells. Primarily in this case it's for energy use, not cholesterol transport. So once the triglyceride and some of the cholesterol has been adequately distributed through the tissues, these very low density lipoprotein particles they've gone through a transition to LDL particles, which are very poor in triglyceride content but high in cholesterol. Ideally, these LDL particles are then removed from circulation by the liver and the process can start over again, with these LDL particles being broken down to their constituent parts and repackaging so that this particular cycle occurs again. This describes the endogenous pathway of lipid transport. Specific points on the endogenous pathway. So triacylglycerol and cholesterol can be either synthesized in the liver or obtained from circulation, whether that be from chylomicron remnants or from adipocyte non-esterified fatty acid liberation. ApoC and ApoE, as well as cholesterol ester, are acquired from HDL in circulation. Again, the ApoC is required for the activation of lipoprotein lipase, which catalyzes the hydrolysis of triacylglycerol. ApoC, at some point in the conversion from VLDL to LDL, is transferred back to HDL. The remnant particle, or more specifically intermediary density lipoprotein, or IDL, if it contains an ApoE, it can be taken up directly by the liver via the ApoE/remnant receptors at the liver. However, if it does not, the ApoE is lost again to HDL, and the hepatic lipase will continue to act on this intermediary density lipoprotein to liberate even more triglyceride until you have a very cholesterol-rich LDL particle. The LDL particle is then removed because of the LDL receptor family, which recognizes the ApoB100 as its ligand. This summarizes very briefly the endogenous pathway of lipid transport in our bodies. Next, we're going to cover the reverse cholesterol transport pathway.